Friends, in class 12th, the P block elements, we were discussing about group 16 elements, and in this video we will discuss about dioxygen, its preparation, properties and uses, and we will also discuss about classification of oxides. First come to the dioxygen and its preparation. Dioxygen means O2, can be obtained in the laboratory by the following ways. First method is by heating oxygen containing salts such as chlorates, nitrates and permanganates. See one example, this is potassium chlorate. When heated in the presence of manganese dioxide as a catalyst, it will give KCl and dioxygen. Another one is by the thermal decomposition of the oxides of metals, low in the electrochemical series and higher oxides of some metals. For example, silver oxide. When heated, this will give oxygen. Mercury second oxide. When this is heated, this will give oxygen. Now we can say this is the higher oxide of lead. Actually, lead form two oxides, PbO in +2 oxidation state and PbO2 in +4 oxidation state. That's why when we will heat this higher oxide of lead, this will give PbO and O2. At the same time, if you will take this Pb3O4, this is a mixed oxide of lead. It is the combination of 2 units of PbO and 1 unit of PbO2. When we heat it, in this the PbO2 will decompose to give oxygen. Clear, student? Another method of the preparation of dioxygen, this is hydrogen peroxide, is readily decomposed into water and dioxygen by catalysts such as finely divided metals and manganese dioxide. That is H2O2. When decomposed, this will give O2 and water. On large scale, it can be prepared from water or air. Electrolysis of water leads to the release of hydrogen at the cathode and oxygen at anode. I think you are familiar with this electrolysis of water. Industrially, dioxygen is obtained from air by first removing carbon dioxide and water vapor, and then the remaining gases are liquefied and fractionally distilled to give dinitrogen and dioxygen. In simple way, we can say by the fractional distillation of a liquid air, we will get the dioxygen and dinitrogen. Properties of dioxygen. Dioxygen is a colorless and odorless gas. Its solubility in water is to the extent of 3.08 centimeter cube in 100 centimeter cube water at 293 Kelvin, which is just sufficient for the vital support of marine and aquatic life. We can say this dissolved oxygen is responsible for the survival of aquatic life. It liquefies at 90 Kelvin and freezes at 55 Kelvin. Oxygen atom has three stable isotopes, oxygen 16, oxygen 17, oxygen 18. Molecular oxygen means O2, or we can say dioxygen, is unique in being paramagnetic. Paramagnetic means attracted by the external, weakly attracted by external magnetic field, in spite of having even number of electrons. Dear student, dioxygen is made up of two atoms of oxygen, each atom of oxygen having 8 electrons. It means in O2 there are the 16 electrons are there, even number of electrons are there. But as per the molecular orbital theory, it, that is O2, has 2 unpaired electrons in anti-bonding pi orbitals. That's why this is paramagnetic in nature. Dioxygen directly reacts with nearly all metals and non-metals except some metals like gold and platinum and some noble gases. Its combustion with other elements is often strongly exothermic, which helps in sustaining the reaction. However, to initiate the reaction, some external heating is required as bond dissociation enthalpy of oxygen double bond is high, which is 493.4 kilojoule per mole. These are the some reactions of dioxygen, metals and with non-metals and with other compounds. Like with calcium, it forms calcium oxide. With aluminium, aluminium oxide. This is phosphorus is a non-metal. It forms phosphorus pentaoxide P2O5, but it exists in dimer. That's why we have written P4O10. With carbon, it forms carbon dioxide. With zinc sulfide, it forms ZNO and SO2. CH4, this is hydrocarbon. We can say all hydrocarbons react with oxygen and form carbon dioxide and water. Some compounds are catalytically oxidized. For example, SO2. When react with the O2 in the presence of V2O5 as catalyst, it will form SO3. The same way, HCl, when react with the O2 in the form of CuCl2 as a catalyst, this will give Cl2 and water. Uses of dioxygen. In addition to its importance in normal respiration, this is the essential for living organism, that is respiration process in which oxygen is required, and for combustion oxygen is also essential. In spite of, we can say, other than this normal respiration and combustion process, oxygen is used in oxyacetylene welding. What is this oxyacetylene? When oxygen, see in the setup, when oxygen and acetylene burn, then large amount of energy is produced, and that energy is required for the welding of metals or welding of iron objects. Clear? In the manufacture of many metals, particularly steel. Oxygen cylinders, you are familiar again, in the hospital you can see, are widely used in hospitals, even high altitude flying and mountaineering. You can say that is, if any person is going to a high hill, then there is the lack of air or lack of oxygen. That's why they will carry oxygen cylinder. The combustion of fuels like hydrogens in liquid oxygen provides tremendous thrust in rockets. Okay, you can say that is this, in rocket hydrogen is used as a fuel, and to burn it we use the liquid oxygen. Okay, these are the usage of dioxygen. Classification of oxides. First of all, what is oxide? A binary compound of oxygen with another element is called oxide. Oxide can be simple like magnesium oxide and Al2O3. It may be mixed like Pb3O4. We already discussed Pb3O4. Why this is called mixed oxide? Because this is the combination of 2 units of PbO and 1 unit of PbO2. The same way, this is Fe3O4. This is the combination of 1 unit of FeO and 1 unit of Fe2O3. Okay. And these simple oxides can be classified on the basis of their acidic, basic or amphoteric character. An oxide that combines with water to give an acid is termed acidic oxide. For example, SO2, Cl2O7, CO2 and 2O5. This one equation is, we can write, when SO2 react with the H2O, it forms H2SO3. This is called sulfurous acid. Okay. As a general rule, only non-metal oxides are acidic. Clear? We can say generally non-metallic oxides are acidic in nature. But oxides of some metals in high oxidation state also have acidic character. For example, Mn2O7, CrO3 and V2O5. Oxides which give a base with water are known as basic oxides. For example, Na2O, CaO, BaO. When CaO reacts with the H2O, it forms calcium hydroxide, which is a base. In general, metallic oxides are basic in nature. But some metallic oxides exhibit a dual behavior. It means they show characteristics of both acidic as well as basic oxides, and these oxides are known as amphoteric oxides. They react with acids as well as alkalis or bases. For example, aluminium oxide. You can see this reaction. Aluminium oxide, when react with the HCl, this will form a one salt, complex salt. Okay. Its name is hexa aqua aluminium third. Okay. The detail of such type of compounds we will discuss in the coordination chemistry. This is Al2O3. When reacts with the alkali NaOH, this will form sodium hexahydroxoaluminate third. Okay. There are some oxides which are neither acidic nor basic. Such oxides are known as neutral oxides. Examples of neutral oxides are CO, NO and N2. Students, thank you.